Hi, I'm Lim. So today we are going to fix the iPad. What's the model? Let me see. What's the model? Is it? It's a A1823. Okay. This iPad cannot be powered on, and the first thing we must check whether it's a charger port problem or the battery issue. Okay. So they are not the problem, and the next step, proceed to check the motherboard and other things. Okay, so the first thing we can test is, we can also test how's the charging by connecting the charger. Okay, so connect it. Let's see the response. 0.6. Okay, so it will still have a charging response, but still cannot be turned on. So whatever the problem is, we need to connect the power supply. Okay, I already removed the board for me, so it will be easy to remove. I will check the battery connector here. I have to look for the ground, so make sure one of it is ground. Okay, so this is the ground. If you are not sure, you can also hold the shield like this, so to look for the ground like this, and this guy is the ground. They all are the ground. So the red will be connected to here, the black will connect to here. Okay, but before we proceed, we also need to check the resistance of this. So 390 something is still working. Good. And then we connect to the power supply. But before we connect, we need to put something in here, so then the red connector, it won't short the ground. Okay, because it is the clip up and down, and this guy is the ground. So we'll put the things in here like this. Okay, and then connect the rig on top, and the black on whatever ground we'll have. Okay, we'll just connect to the shield here, but make sure the rig is only connect to this pin, okay, not the others. I don't want you to damage the other things. Okay, so make sure the rig connector do not put in the other pins. Okay, it might kill the others line. So once we connected, we are going to give some power. Okay, immediately it short. So make sure you didn't accidentally touch anything else. So I didn't. So it's short. Measure the resistance again. There's nothing wrong in the battery connector. Okay, if like this, then it's more likely the power circuit have problem, you know. But you have to also make sure it is not your power supply problem. Okay, it might be your cable is shorting each other. So make sure the connector is okay. So give some power, about 1.1, and then you measure it. So see, 1.1. So power supply cable is nothing wrong. then for sure it's the board issue. So to repair the iPad, this kind of problem is quite easy. It's more easy than the iPhone. So we take off the shoe. Roughly take a look to see whether someone repaired it before. So it's an A9 iPad. Okay. So if the battery connector is not short, then it must be the next circuit, you know, because the battery connector power, battery VCC, will go through the IC, some kind of like it's a MOSFET IC, you know. It will go through the MOSFET IC. Okay, so I believe this is the MOSFET IC. So it seems like it. And he also near to the power IC. I don't see other ICs like him. Okay, so this guy more likely is a MOSFET. Okay, to confirm this, we need to get the model code. This is a A1823, and look at the schematic. Okay. Okay, look at the iPad. Yeah, it doesn't say the model, it doesn't show like that, so we need to Google it first. Google and look for the iPad A1823. So the iPad version A1823 is 2017. So and then come back to here, click on 2017. Okay, so we are exactly look at the board like this. So let's click the power connector here, and then you will see the VCC power, the battery. By the way, you won't see any other information, you know. You won't see there's a name, the label, things like this. Maybe the model is too new, or maybe they didn't update this kind of schematic. But it doesn't matter. I still have the Mac to look. I can guess what the line is doing, what the line is for. So I click the power connector here. I see the power go to this IC, and here power IC will get the power, and then some caps and now something over here. So but this line is not short. Okay, as we see just now, we measure the resistance. It was okay. Okay, let's measure again. So measure this 395. So on the top there, they are the same, you know, this kind of line. Okay, 397. So they are all okay. This highlighted area means they are okay. We also need to switch to the buzzering mode. Make sure this is not half short. Okay, it isn't half short. This is the IC I said just now. Okay, this is what we call MOSFET. Okay, the MOSFET is designed like this. So there we have a one pin as a gate, and then there's a source and drain. You know, he will pass on the power to the next section. So this is the next section. Okay, so the next section is kind of like the main power section. So you need to measure one of the thing here to know whether they are short or not. I will look at the power IC, and this is the MOSFET. So all these cap, they are the VCC main, same as the iPhone. So make sure 0000 0000, they are short. Okay, they are full short. So switch to the browsing mode. Okay, they are full short. So means one of the thing here is short. Okay, it might be the IC or it might be the capacitor. Okay, but normally it's the capacitor. The lifetime capacitor would be shorter than the IC itself. Unless the IC is damaged by human nature, or maybe water damage. Okay, so what we're gonna do is I will jump the power to here. Do not jump to the connector there. Okay, do not connect a battery to look for this problem. You won't see it because the MOSFET will interfere your judgment. So that's why we need to jump to the next section, right? Which is this one of the highlight area, and not here. Okay, jump to here. So iPad is easy. You just click one of the ground here. Okay, you just click one of the ground here, and then the red one just solder on one of the thing. I will just solder on here. So done. And we are going to inject the voltage again and use the thermal camera. Without thermal camera, you have to use freeze all the shit, or either you have rosin all over. It's dirty, man. So that's why it's best you use a thermal cam to do so. Take off this. Okay. They're not getting heat. Strange. This is the guy get heat. Strange. Okay, so there seems to be a big cap that is blinking. Okay, in this case I have to desolder this thing and then connect it to the other things, and then I solder to the other point. Okay, one of the guy here. Turn it on off like this. So this is a big capacitor. Alright, so once I remove this, I believe the shot will be gone. Okay, this guy. Alright. Alright, we don't need this. Before we remove, we also to see whether they are short. Okay, so okay. after remove, we need to measure this guy. Okay. If it is connected, I mean it is short. Okay, it is connected, it is short. This guy shouldn't be short like this. And then we measure the things here. Check back the resistance. Okay. $78. It will slowly come back. So slowly come back. Let's pick up 120. Okay. The resistance will fully back once we power up the device only. Okay. And we need to replace the thing back. Okay. It will run without, but we still need to replace it. I think I can take this from other iPad. We are going to look for the schematic. Where when ZXW doesn't show any label name at all, means we don't have the schematic. But we can look for the other similar iPad design and look for the MOSFET. Okay, so let's say I will see iPad 2. So battery will go to this guy, and you can see these two guys, they are similar things. Yep, can use. Okay, so the plus sign is the voltage line, and this side is the ground line. Okay, I will just remove this guy and use it. So we don't have the schematic, and I can only do these similar things. If I have, I will take and then replace according what the schematic say. Okay. Measure resistance. Seems like a bit low, but it should be fine when I plug in the power. Okay, we don't know until we plug in. So that's why resistance logic is very important. Once you learn the resistance logic, you will know some of the circumstance do not believe in the resistance. Okay, the board is still hot. Oh, I think we should try the power supply first. Okay. Then inject the voltage. Switch back to 1A. So you see the voltage is entering and it doesn't show a bit of short. And then we measure the voltage inside the board Okay, especially this is the VCC main. Okay, this is the part where we need to measure. Okay, let's see. If I put 4.2, it will have 4.2. So the power is reaching inside. And then if I turn this off, if I measure the resistance, see, the resistance is going back. Okay, if I disconnect them, the power supply, so it's getting higher. Okay, now we try to press the power button. Okay, so one of it should be the power button. Okay, so as you can see, it will jump to 80 and then drop back. So it will be about 100 mA and then drop it back to 0. So it means nothing else short. You can turn this on, okay, by pressing the power button. Okay, so the device can be turned on. Turn this off, connect back to the housing. So now it's assembled. I just connect the touchscreen and the LCD to test. So the other things will be assembled by my other team. So try to turn it on. If you cannot turn on, okay. If you cannot turn on, just charge in the power. Just charge in the charger port. He will reactivate the battery. Okay, so it's on now. There's a passcode page. Okay. Alright, so we don't have the passcode. I can't do anything. Yep, so that's it. So that's how we repair the iPad that cannot be turned on, but not every case is the same. This one is not common, you know. So this is one of the big cap that gets shot. It will work without replacing this guy back. No. But I prefer to try to do it as original as possible. That's it for the shank.